You are listening to AI with Shaily, where we crack open the fascinating world of artificial intelligence to bring you the latest and greatest in AI innovation. I'm your host, Shailendra Kumar, and today we're diving into a topic that often stays behind the scenes but is absolutely critical to the AI revolution: the hardware powering our AI dreams. Lately, there's been a noticeable buzz across social media and development circles about the very chips crunching numbers for AI models like GPT and vision transformers. You see, traditional silicon processors, the CPUs and GPUs we're all familiar with, are starting to hit some serious walls. Data has to zip back and forth between processors and memory, and that tug of war creates latency delays. Plus, with architectures like Apple Silicon, while energy efficient, developers face new challenges. No access to the neural engine for AI tweaks, making it tougher to craft smooth, unified AI workflows compared to the flexible landscape NVIDIA CUDA offers. Imagine trying to choreograph a dance when half your troupe can only rehearse separately. That's the developer's dilemma right now. The stakes here are high because AI models are ballooning in size and complexity. This means semiconductor chips must juggle raw computational power without burning through energy or overheating. The industry is moving at a breakneck pace, advancing transistor scaling down to 2 and 3 nanometers and experimenting with clever packaging that essentially removes traffic jams between the chip's processing and storage parts. This synergy, often called hardware software co design, is where magic happens. When chips and algorithms are optimized hand in hand, performance skyrockets without the typical energy price tag. As someone who's spent countless sleepless nights debugging code and wrestling with inefficient hardware, I find this synergy not just exciting, but essential. Big players are sprinting into this arena with purpose. 1. Apple's quietly crafting the AC/DC AI chip designed to nestle AI smarts directly inside consumer gadgets. 2. Meta's rolling out the next-gen MTIA accelerator with triple the performance punch for training AI models. 3. Microsoft's Maya 100 is strutting its stuff on Azure despite some delays on their Braga chip. 4. OpenAI is gearing up to launch its own custom chip next year, tapping into TSMC's cutting-edge 3 nanometer tech. This hardware orchestra aims to conquer data throughput headaches, boost integration, and slice energy costs. Yet, it's not just about speed or power. Sustainability and supply chain stability are entering the spotlight. The semiconductor world faces pressures to reduce environmental impact while also addressing talent shortages and fractured hardware ecosystems by adopting smarter chip design automation and software abstraction layers. So, what's the big takeaway here? AI's future depends on overcoming the triple threat of energy hunger, latency bottlenecks, and hardware fragmentation. The race is on, with the latest semiconductor breakthroughs and AI specific chips leading the charge, paving the way for smarter, greener, and faster AI systems. Here's a bonus tip for all you AI enthusiasts and developers. When choosing your next AI platform or hardware, consider not just raw compute, but how seamlessly hardware and software integrate and how open the ecosystem is to your development needs. Flexibility often beats sheer horsepower in the long run. I'll leave you with some food for thought from Alan Kay, who once said, "The best way to predict the future is to invent it." In AI hardware, that's exactly what these innovations are doing, building tomorrow's tools today. Catch more insights and deep dives on my YouTube channel. Follow me on Twitter and LinkedIn. And don't forget to check out my articles on Medium. If you found this segment valuable, hit subscribe and drop your thoughts in the comments. How do you see AI hardware shaping the next decade of innovation? Until next time, this is Shailendra Kumar signing off from AI with Shaily, where the future meets the present, one transistor at a time.